Hello students, in previous session we have studied Hyperledger and Hyperledger fabric. We know what is Hyperledger fabric. Hyperledger uh, fabric provides a modular structure. Uh, the industries can develop and design their blockchains using the Hyperledger. There are different design goals of Hyperledger that also we have studied. It has a modular structure. It is portable. It can be portable on any kind of machine, interoperable, then scalable. Uh, and these features, various design goals we have studied in the previous session. Also, we have studied the architecture of hyper ledger, and also we have studied the different services provided by the hyperledger: identity services, policy services, blockchain services, then consensus services, and that we have studied in the previous session. So in this session we have to study the components of hyperledger fabric. So we will try to understand the components of Hyperledger fabric in this session. So this is the syllabus of Unit 5, in which we have to study the Hyperledger fabric. Hyperledger components. So there are various components that can be part of the Hyperledger fabric blockchain. These components include but are not limited to the ledger, chain code, consensus mechanism, access control, events, system monitoring and management, wallets, and system integration components. So in previous session we have studied what is chain code. Chain code implements the business logic agreed upon by the all participants in the Hyperledger fabric. So chain code is similar to the smart contract in blockchain. Then we have studied the membership services and consensus mechanism. So we will try to explore more about these Hyperledger components in this session. So first component of the Hyperledger is peers. Peers, or we can say nodes, user nodes that participate in the Hyperledger fabrics. So peers participate in maintaining the state of the distributed ledger. So we know that what is the state of the distributed. There is some state of the distributed. Then we receive the inputs. On that inputs are processed, and state of the distributed ledger is modified. But before modifying the state of the system, all peers, all participants must agree on the new state of the system. If all participants agree on the new state through the consensus mechanism, then the state of the system will change. Every node has the copy of the ledger, and that copy should be consistent. So change should be there on every peers, on every node in the fabric, or you can say blockchain. So these peers hold a copy of the distributed ledger. Each peers hold a copy of the distributed ledgers, and peers communicate via gossip protocol to each other. There are three types of peers in the Hyperledger fabric network: endorsing peers, or you can say endorsers. Then second type of peer is committing peers, or committers. These peers are also called committers. And third type of peers are submitters. So you will see what is this endorsers, committers, and submitters. So first type of peer is endorsing peer or endorsers, which simulate the transaction execution and generate a read write set. Endorses execute and endorse the transaction. So this type of peers execute the transaction, and they will endorse the transaction. It should be noted that an endorser is always also a committer too. So endorsement policies are implemented with chain code and specify the rules of transaction endorsement. So these endorsement policies are implemented with the chain code. So we know that what is chain code. Chain code is a agreement between the participants, or you can say smart contract, and this smart contract specify the rules for the transactions. If just that rules are satisfied, if that rules are if the transaction is going as per the rule, then that transaction is allowed to execute. And then second type of nodes are committing peers or committers, which receive transaction endorsed by the endorsers. This type of peers verify the transaction and then update the ledger with the read write set. A committer verifies a read write set generated by the endorsers along with the transaction validation. Then third type of peers in the Hyperledger Fabric are submitters. Submitters is the third type of peers which has not been implemented yet. It is on the development roadmap and will be implemented soon. So this third type of peers are permitted, not permitted. So third type of peers, submitters, are proposed, but such kind of peers are not implemented. This type of peers are on the development phase. So these are the three types of peers that can exist on the Hyperledger Fabric: endorsing peers, committing peers, and submitters. Then there are orderer nodes. So we know that in blockchain, transactions should be processed in sequence in the same order on every node, and if the transactions are not processed in the same order on every node, then the results will not be deterministic. We cannot predict the results. So the sequencing, the ordering of the transaction is very important. If the transactions are processed in the same order on every node, then that nodes will be the results will be same on every node, every peer. So ordering nodes, the function of these nodes is to sequence the transaction, to put the transaction in order. So ordering nodes receive transactions from endorsers and along with read write sets, and these ordering nodes arrange the transactions in a sequence and send those to the committing peers, and committing peers then perform validation and committing to the ledger. So committing peers, after receiving the transactions in order, then these committing peers perform the validation of the transaction, and committing means finalizing the transaction, and to store the transactions onto the ledger. So all peers make use of certificates issued by the membership membership services. So we know that membership service provider is nothing but the certificate authority which provides e-certificates to the members, and if the member has the e-certificate, then that members can join the Hyperledger Fabric. Then clients are software that makes use of APIs to interact with the Hyperledger Fabric and propose transactions. So clients are at the client side, there is a software that makes use of APIs to interact with the Hyperledger Fabric and propose the transaction. So this is one of the component of the Hyperledger Fabric, that is client. So another component in the Hyperledger Fabric is channels. Uh, this concept of channels is very important in the Hyperledger Fabric. So if some parties want to do some kind of confidential communication, or either they want to form their separate blockchain, so such type of group of peoples can form a blockchain using the concept of channels in the Hyperledger Fabric. So the communication in the channel is for a particular participants. So channels allow the flow of confidential transactions between the different parties on the network. They allow using the same blockchain network but with separate blockchain. So we can form a separate blockchain with the channel with some group of peoples, but these channels can communicate. There are different types of such type of channels on the Hyperledger fabric, and these channels can communicate with each other. So if required, so channels allow only members of the channel to view the transactions related to the them. So in channel there are some members, and that members can view only the transactions, and all other members on the networks will not be able to view the transactions. But if it is necessary to be have the communication between the channels, then such type of communication between different channels can be allowed in the Hyperledger fabric. Then word state database reflects all committed transactions on the blockchain. This is basically a key value store which is updated as a result of the transactions and chain code execution. So this word state database is nothing but a we can say ledger that stores all the transactions, all committed, which reflects all committed transactions on the blockchain, and this is basically a store which is updated as a result of the transactions. When the transactions are processed through the consensus mechanism and chain code execution, then this word state database is updated. So for this purpose, either level DB or couch DB is used. Level DB is a key value store where couch DB stores data as JSON objects, which allows rich queries to run against the database. So we know that level DB is a default, and if we want to have rich queries to fire on the Hyperledger fabrics, then couch DB store can be used. This concept we have studied in the previous session also. Then transactions. Transaction messages can be divided into two types: deployment transactions and invocation transactions. So there are two types of messages for transaction processing. The former is called, or you can say, deployment transaction is used to deploy new chain code to the ledger. If we want to deploy some new business logic, new smart contract, then deployment transactions messages can be used. And the latter means invocation transaction messages is used to call the functions from smart contract. First is to deploy the logic, and second is to call the various functions of the smart contract, we can say chain code. Transaction can be either public or confidential. Public transactions are open and available to all participants, while confidential transactions are visible only in a channel open to its participants. So there are two types of transactions: public transactions and private transactions. So public transactions are open to all participants, and confidential transactions are visible only in a channel open to its participants. Then membership service provider. Provider is another component that provides a membership to the participants or nodes on the Hyperledger. So membership provider is a modular component that is used to manage identities on the blockchain network. So this provider is used to authenticate clients who want to join the blockchain network. So before any participant wants to join the blockchain, then that blockchain is authentic, that node, that client is authenticated by this membership provider. So we can say certificate authority. We have discussed certificate authority in some detail earlier. And then certificate authority is used in membership service provider to provide identity verification and binding service. So this is the function of the membership service provider component which provides membership. It authenticates the users, it provides the certificates to the clients, and the clients, those have e-certificates, that clients can join the Hyperledger Fabric network. So this is the concept of this membership service provider in the uh, Hyperledger. Then smart contracts in Hyperledger Fabric. Same concept of smart contract is implemented, but they are called chain code instead of the smart contract. So in previous session also I have said that the smart contracts are called chain code in the Hyperledger Fabric. So chain code is nothing but a smart contract which verifies the business logic, and transactions are executed as per the business logic. So this chain codes will check that whether the logic is business agreements, whether the agreements are met or not, whether the agreements are satisfied or not. If the agreements are satisfied, if the business conditions are met, then the chain code will allow the transactions to proceed further. So these smart contracts are nothing but chain code. Chain code contain conditions and parameters to execute the transactions and to update the ledger. Chain code is usually written in Golang and Java. So this is the concept of chain code. Instead of smart contract, we call the smart contracts as a chain code in the Hyperledger Fabric, and this chain code will verify the business conditions and parameters to execute the transaction and to update the ledger. If business conditions are met or satisfied, then it will allow the transactions to process. Then crypto service provider, as the name suggests, this is the service that provides the cryptographic algorithms and standards for usage in the blockchain network. And this service provides key management, signature, and verification operations, and encryption and decryption mechanism. This service is used with the membership service provider to provide support or cryptographic operations for elements of the blockchain, such as endorsers, clients, other nodes, and peers. So after this introduction to this component of Hyperledger Fabric, in the next session we will see what an application looks like when on a Hyperledger network. So how the application will be processed, we will see in the next slide. So you can see how the applications on blockchain will look like. So you can see the diagram. There is a user interface front end, and there are APIs, and user interface is written in HTML or JavaScript, and users can communicate. To the blockchain through the APIs. And the transactions will happen. You can see the chain code. Chain code contains the business conditions. Our chain code is nothing but the smart contract in the Hyperledger Fabric. So a typical application on Fabric is simply composed of user interface, usually written in JavaScript or HTML, that interacts with the backend chain code. Or you can see this user interface interacts with the backend chain code that contains the conditions and parameters to execute the transactions. So Hyperledger provides various APIs and command line interfaces to enable the interaction with the ledger, and these APIs can include interfaces, different types of application interfaces that include for identity, transactions, chain code, ledger, network, storage, and events. So this is how the applications can communicate with the ledger, or you can say Hyperledger in the Hyperledger Fabric. So students, in this session we have studied the different types of Hyperledger components, and also we have studied the applications of how the application on Hyperledger blockchain will interact with the ledgers. So this also we have studied in this session. We will stop here. Thanks for watching session. Goodbye.